ladies and gentlemen. Mr. Mueller here. This week, again, we're going to continue to look at our standard on operations on polynomials, but we're going to now look at a different target, AB, which has to do with factoring. So, an important thing about factoring is, ladies and gentlemen, it's probably one of the most widely used or asked about concepts on the ACT math test. So please make sure you look through this and you can do this. Because on the ACT test, ACT math test, it's fairly important. So what I'm going to have you do first is, I'm going to have you, just to make sure you're ready, give you a little background, I'm going to have you do the next two problems on your own. The first one says multiply 5a squared times 3a squared minus 5a plus 8. And then the second one says I want you to find GCF means greatest common factor of 18x squared y, 12xy squared, and negative 6xy. That one may be a little more difficult. We'll come back and look at those. So again, go ahead and pause the video, see if you can do those two, and then we'll come back and see if you're right. Okay, so now that you've had a chance to do these, let's see how you did. On the first one, basically all we're going to do is our distributive property. We're going to take 5a squared times each of these three terms in that three-term polynomial. We call it trinomial. So the first one we're going to do is take 5a squared times 3a squared. And if you do that, you get 5 times 3 is 15. A squared times a squared, you add the exponents, is a to the fourth. Now we're going to take 5a squared times negative 5a. So you take 5 times negative 5, that's negative 25. A squared times a to the first would be a to the third, because again, you add the exponents when you multiply terms. And then 5a squared times 8, you just take the 5 times the positive 8, which is positive 40, and then there's nothing to combine the a squared with. So there's your answer, 15a to the fourth minus 25a to the third plus 40a to the second. So there, and again, none of those are like terms, you can't combine them together. As a matter of fact, if we have three terms in this polynomial right here, we should have three terms in our answer. Okay. Now let's take a look at this one. Find the greatest common factor of 18x squared y, 12xy squared, and negative 6xy. Well, greatest common factor, okay, and I'm going to write that out. Greatest common factor is basically as it says, okay? Find the largest factor that all of these three terms have in common. Now, the thing is, it may help you if you want to rewrite them out as factors. So if you take a look here, I'm just going to start with 18. I'm going to leave 18 as 18. But, ladies and gentlemen, x squared I'm going to write as x times x. And then I'm going to go ahead, ladies and gentlemen, as y. You know what? I'm going to do this. I'm going to write out 18. I'm going to factorize 18 too. Okay, remember, 18 is just 2 times 9. And that's 2 times 3 times 3. That gives you 18. And then x squared is x times x, and then y. So there's basically what 18x squared y is. Now I'm going to do the same thing for 12xy squared. Well, 12 is 3 times 4. 4 is 2 times 2. So I'm going to take 2 times 2 times 3. That gives me 12 times x times y times y. Okay? And then lastly, I'm going to multiply, or I'm going to factor out negative 6xy. Well, negative 6 is just negative 1 times 6. And I should say 6 is 2 times 3, because let's try and factorize that. And then times x times y. Now, to find the greatest common factor, ladies and gentlemen, all you're doing is going through all these and finding out what factors do they have in common. Okay? Well, if you take a look here, the first term has a single 2. This has 2 2's, and this has 1 2. Okay? So in other words, what do they all have in common? They all have in common one factor of 2. Now, yeah, I know what you're saying. You're saying, yeah, but there's 2 2's right here. Yeah, but this one does not have 2 2's, and neither does this. The most 2's they have in common is just 1, and so that's going to be a part of our greatest common factor. So if I write the greatest common factor here, ladies and gentlemen, it's going to be 2 so far. Now, let's see if they all have 3's, and they do. This one has 2 3's, this one has a single 3, and this one has a single 3. So how many 3's do they all have in common? They all have a one factor of 3. I know, again, this one has 2 factors of 3, but none of the others do. So a single factor of 3 is what they all have in common. Now we also look at the negative 1. we're not going to worry about that because the only one that has a -1 in it is the last term. Okay, none of these others have a -1, so that's not a part of our greatest common factor. If they were all negative, then we would have that -1 as a greatest common factor. Okay, so now we go ahead and we look at the x's. This has 2 x's, this has 1 x, and this has 1 x, so just like before, a single x is what they all have in common. Okay, and then you look at the y's, it's the same thing. Here's a y, there's 2 y's, and there's a y. What do they all have in common? They all have a single y in common. Now, if they all had 2 factors of y, then we put a y times a y down there, but they all have just a single factor of y in common. So if we simplify that, the greatest common factor is 6xy. That is the largest factor that they all have in common, a 6x and a y. Okay? Now, we are not going to have to expand these out all the time. I'll actually show you a shortcut when we start factoring, ladies and gentlemen, that you can look at. So for instance, 18, 12, and 6, you don't have to factor them out. You can just say the largest number that goes into 18, 12, and 6 is 6. Okay? You have an x squared, an x, and an x. Well, what's the most x's they all have in common is a 1. They all have a single x. And a y squared, and a y, what do they all have in common? A y. So these are just the warm-up problems to get you going. Now we're going to look at this process of what we call factoring in the next video.